last video, we talk about how seasons on Earth are not caused by how close Earth is to the sun in its orbit. And we also hint at the fact that it's actually caused by the tilt of the Earth. And so in this video, I want to show you how the tilt of the Earth causes the seasons to happen. So let's draw. So I'm going to try to draw as many diagrams as possible here, because at least for my brain, they help me visualize what's actually going on. So we can imagine a top view first. So let's have a top view. That is the sun right over there. And let me draw Earth's orbit. So Earth's orbit maybe looks something like that. Let me draw it almost. It is almost circular, so I'll draw it as something that's pretty close to a circle right over here. And I'm going to draw Earth at different points in its orbit, and I'm going to try to depict the tilt of its rotational axis. And obviously, this is not drawn anywhere near close to scale. Earth is much further away from the sun and much, much smaller than the sun as well. So I'll draw the Earth at that point. And at this point, the Earth will be tilted away from the sun. So Earth's tilt does not change if you think about the direction, or at least over the course of a year, if we think about relatively small periods of time. It does not change relative to the direction that it's pointing at in the universe. And we'll talk about that in a second. So let's say right over here, we are pointed away from the sun. So we're up and out of this page. So we are up and out. So if I wanted to put some perspective on an arrow, it would be up and actually it would be more like up and out of this page. So that's the direction if you were to come straight out of the North Pole. And if you were to go straight out of the South Pole, you would go below that circle right over there. And if I wanted to draw the same position, but if we're looking sideways along the plane, the orbital plane or the plane of Earth's orbit. So if we're looking at from that direction, so let me do it this way. If we're looking at directly sideways, this is the sun right over here. This is the sun. That is the sun. And this is Earth at that position. This is Earth at that position. This is Earth right over there. If I were to kind of draw an arrow pointing straight out of the North Pole, if I were to draw an arrow coming straight out of the North Pole, it would look something like this. It would look something like this. So this arrow and this arrow, they are both popping straight out of the North Pole. And so when we talk about the tilt of the Earth, we're talking about the tilt of its orbital axis, kind of this pole that could go straight between the South Pole and the North Pole. The angle between that and a pole that would actually be at a 90-degree angle or perpendicular to the plane of its orbit. And so compared to if it was just straight up and down relative to the plane of the orbit. So this right here is the angle of Earth's tilt. Let me draw that a little bit bigger just so it becomes a little bit clearer. So if this is the plane of the orbit, we're looking sideways along the plane of the orbit. And this is Earth right over here. So this is Earth. My best attempt to draw a circle. That is Earth. Earth does not rotate. Its axis of rotation is not perpendicular to the plane of the orbit. So this is how Earth would orbit. This is how Earth would rotate if it was. Earth rotates. Earth's rotational axis is at an angle to that vertical relative to the plane of its orbit, I guess you could say it. It rotates at an angle like this. So this would be the North Pole. That is the South Pole. This is the South Pole. And so it rotates. It rotates like this. And that angle relative to being vertical with respect to the orbital plane, this angle right here for Earth right now is 23.4 degrees. 23.4 degrees. And if we're talking about relatively short periods of time, like our lifespans, that is constant. But it is actually changing over long periods of time. That is changing between, and these are rough numbers, it is changing between 22.1 degrees and 24.5 degrees, if my sources are correct. But that gives a rough estimate of what it's changing between. But I want to make it clear, this is not happening overnight. The period for it to go from roughly a 22-degree angle to a 24.5-degree angle and back to a 22-degree angle is 41,000 years. 41,000 41,000 years. And this long-term change in the tilt, this might play into some of the long-term climatic change. Maybe it might contribute on some level to some of the ice ages that have formed over